Timers there.
Okay. So yeah, I'm a microbiologist. I come from a slightly different perspective. When I look at an aquatic system, I think about what types of bacteria are there, what they're doing. So I'm going to tell you about a couple of different projects that I've gotten involved in, and I have some collaborators here. In fact, I work with Andy Madden, who you just heard from. Okay. A couple of years ago, in 2017, we got funded from National Science Foundation to work on methane-consuming bacteria, that is, bacteria that oxidize methane. And, oh, okay, I got to stand here. There's a number of collaborators on this project, some people in geology and geophysics, microbiologists, and then some others at OU, and then we have two external collaborators, South Dakota State University as well as Montana State University. So the goals for this project are to look at methane oxidizing microbial communities and to determine what types of bacteria are involved, and then to isolate novel methane oxidizing bacteria. Of course, methane is a source of energy, but it's also an important greenhouse gas. It's produced in all these natural systems. Produced in all these different systems. This other is actually the aquatic systems, lakes, rivers, wetlands, that sort of thing. So when methane is produced, it actually diffuses upwards in these systems, and it's oxidized by, at least partially oxidized by methane oxidizing bacteria in surface soils and sediments and waters. And we've been looking at a variety of systems, including things like Duck Pond, Honey Creek, places you're familiar with, like Thunderbird, Norman Landfill, Great Salt Plains. And this is a sulfur and methane spring in southwestern Oklahoma that we've been studying for a number of years, and we did a Native American summer research program out there. Through our collaborators, we've been working at a deep underground research facility. This is a facility that where you can sample groundwater that's about 5,000 feet deep, and also Yellowstone National Park. So another project that we've been working on is looking at cyanobacterial bloom microbial communities. This is a project that was recently funded with Dave Hambright in biology. And we're mainly focused, so here's our collaborators, Dave and people at Auburn, UNC, and James Madison. As you know, cyanobacterial blooms are a global problem. They're also a problem in Oklahoma. This is what it looks like. The main issue, or one of the major issues, is the fact that these microorganisms produce toxins and cause a number of problems in drinking water. So, Microcystis is perhaps the major cyanobacterial bloom problem, and this organism grows in aggregates with a variety of microorganisms. These microorganisms support the bloom community to allow to maintain the bloom. So the approach here is to sample a variety of lakes, a variety of microcystis communities throughout the world, and to look at the microorganisms to try to determine key components of the microbial community, those that are sustaining the bloom. So there's a variety of approaches, including the use of these mesocosms, and we'll be also using microcosms as well. Thanks for your attention.